And stop me at any point, you know, you've got a question or whatever. So a lot of what we're going to look at deals with sequences today. Okay, so that's sort of the big math topic that we need to investigate before we get into our algorithm to build our rosette. So, oh, I love that this little bar is like in the way of my thing. There we go. All right, so sequences. So a sequence is basically just a list. We've all made lists, right? You can make a list of anything, whether that list is a list of numbers, a list of things you need to get from the grocery store, a list of points, a list of line segments, a list of polygons. Okay, so it's just a list. And actually GeoGebra by default names sequences L1, L2, L3 because they are lists of things, right? And when you're constructing a list, they have an order, okay? And sort of the fancy math definition of a sequence is that you have this one-to-one correspondence with the set of natural numbers, okay? So natural numbers being 1, 2, 3, and we're just looking at finite sequences, so they end at some number n, okay? And you iterate your sequence by ones, right? So you're not skipping values. Although I mean, there are cases where you could define a sequence where you're like skipping things, but we're not skipping things, okay? So when we're building these in GeoGebra, let me look at sort of a specific example that we're going to look at. So in GeoGebra, our sequences are basically going to look like we're defining a sequence of the thing we want a sequence of. Right, so whether that thing is a point, whether we're trying to rotate something, whether we're trying to build a segment, whatever that thing is. So it's a sequence of this thing, and then usually that thing has some definition of how we build it, and that's kind of what is going to go in here. Okay. And then we have to tell it how we want to iterate it, okay? And so that's where this these other variables come in. So most of our sequences are going to look like blah, 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 this thing we want to do, and then a K, and then a 1, and then an N often, okay? And so what does this mean? So early on, you saw the little sliders, right? So that slider just holds an integer value that we call n. So this n here, and we're not always going to end on n, but n is pretty common value to end on. So this is the integer value held in our slider. Okay. And K is going to be our index variable. That's what we call it in mathematics. And basically, like, K takes on every single integer value or whole number value from 1 to n. So this is our starting value of K, and this is also I mean, so the the thing n happens to be the integer value held in our slider, but what goes in that spot is our ending value of k. So we have this sequence that's going to involve these variables n and k. Then we want to tell it our index variable, which it doesn't have to be k, but I, j, and k are pretty common index variables. Then we want to tell it where the starting value for k and the ending value for k. So let's look at kind of a concrete example first, and then kind of break down how this is going to work. So one of the first things that we're going to do is, right, we always kind of start with our points A and B, right, that build this circle, okay? And so one of the first sequences that we're going to build is we're going to rotate point B iteratively around point A to build the vertices of an n polygon, okay? And so if I want my polygon has to have n sides and n vertices, right? So n is that value held by our slider. Then what I want to do is I need to think about making n-fold divisions of my circle, right? And we could either think in terms of degrees or radians. So I could think about 360 degrees divided by n, or I could think about 2 pi radians divided by n. Okay.
So, sorry, can you explain what a radian is? I didn't understand that when you were like,
oh yeah.
That doesn't mean anything to me.
Yeah, so let's talk radians. So a radian, let me draw a picture over here. So a radian, so if this is my radius, and this is an arc here, and this is some angle theta, okay? So the definition of 1 radian is the angle subtended by an arc S that is equal in length to the radius. So if you imagine the radius of your circle stretched along the circle, that angle is 1 radian.
Okay.
Okay. And I can fit approximately 6.28 of those in one circle, right? Pi is approximately 3.14, 2 pi being approximately 6.18. Okay. So 360 degrees is 2 pi radians, 180 degrees is pi radians. And the reason that I really prefer radians over degrees is just because of the fractions are nicer, I feel like. The numbers are smaller. I mean, you have this pi in there, which might feel kind of weird, but I would rather deal with the number 2 than the number 360. Like 360k over 7 just feels like, I don't know, kind of weird to me. So I normally will just think about 2 pi divided up into n. Okay. So what we need to think about, right? So I'm going to rotate B. So we'll use maybe the example of 8 to help us out. Okay. So I want to rotate B 8 times basically around the circle. Not that I'm rotating 8 whole times around the circle, but 8 divisions of the circle. Okay. And so we need to think about, okay, well, what is this one part here. So if I'm trying to make 8 of them, well, this first angle is the whole circle divided by 8. So I'm going to call this angle 2 pi over n, where n is the number of vertices and sides of my polygon. Okay. And so then that gives me the first rotation. The second one is 2 of those. The third one is 3 of those, etc. Like this would be the 4, 5, 6, 7th one. And then if I came back here, I could think about this as 2 pi over n times 0. Oops, right, 0. Or I can think about it as 2 pi over n times 8. So we end up wrapping back around.
And if we were using degrees, we would have to do the math ourselves and put in a different amount of degrees for each time?
Well, just instead of, if we were in degrees, we would just write 360 degrees over n. So everywhere there's a 2 pi, you could substitute with 360 degrees.
Gotcha. Okay.
And so this value, this 1, 2, 3, you know, blah, 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 up to n is, that's what our index variable is doing. It's iterating the first, second, third, fourth, up to the nth. And I'll even replace 8 here with n. Right, so 2 pi degrees takes us back to, or I shouldn't say 2 pi degrees, 2 pi radians takes us back to 0. Okay. All right, so then what would this, this particular sequence look like? So we would want to rotate point B. How much? Well, we want to rotate it 2 pi over n times k about point A, because that's my center of rotation. And then I want to iterate k from, and this is where we have to be a little bit careful, okay? Because what we're going to find is that if we don't let it come back and overlap with itself, then we don't have a last thing to connect to for later steps. So for this one, we're actually going to do from 0 to n. And so this, like, we'll define a sequence, can I spell sequence, of all this stuff. And so kind of, again, what do all these things stand for? So this is the thing I want a list of. And it's a rotation of things. And then inside the rotate function, I have this B, and that's the thing I want to rotate. Two pi k over n is how much I want to rotate it, or angle I want to rotate it, say. My A is my center of rotation.
I have to go potty.
You're supposed to go around the other way.
Sorry. I have to go so bad.
My 5-year-old, folks. All right. K is my index variable. And so here, K is just limited to this specific thing, okay? I'm only defining that index variable for this particular sequence. So I might use this variable K in multiple sequences, but it's it's a different thing, right? It's not a global value, whereas n is a global value. It's set by that slider, and that value I set in my slider will translate into everything, okay? And so 0 is going to be my starting value of k, and n is my ending value. And so we'll take this point B, we'll rotate it 1 piece of 1/nth of the whole circle, and then 2/nths of the whole circle, and then 3/nths until we get back to n/nths, which is 1. So does that, questions about that?
Yeah, that's clear.
I have a question. When if you were actually putting that in as a sequence, like a written sequence, how would you do the multiplier? I mean, the multiplication. This might be a silly question. The 2 pi over n, is it times k?
Yeah, it's time. So the way I would actually enter it would be, and you'll see this. So I would just put 2 pi k divided by n.
Okay. It's been a long time since I took math class. I wasn't sure if that would be the same result or not the same outcome. I don't remember a lot about dividing fractions, to be honest, especially if they have pi in them and variables. So, okay.
Yeah, so multiplying by k is like the same as multiplying by k over 1. And so
Yeah.
your numerators multiply, your denominators multiply.
That's a good refresher. Thank you.
So like, I mean, we could enter, 2 pi over n, but you have to kind of be careful. Like if you want to multiply this by k, you would want parentheses around it. Otherwise it's going to think that you're just multiplying the n by k.
Oh, okay.
And so you just have to be careful about like order of operations type things, which, the internet loves, right? Order of operations memes. Like, can you solve this? And I'm like, maybe you should have written the problem in a more clear manner. All right. So I think, are we ready to start building in our thing?
Let's do it.
Okay. I'm going to stop sharing this screen. That is where you all will live, so I can see you while I am sharing my other screen. And, let me go ahead and share with you this Google Doc. And so this has every single line of code that we're going to enter, okay? But it doesn't include like all of the why it has explanations of what each line of code is doing, but it doesn't totally get into the whole like why we're doing it a certain way. And so that's, what I'm going to fill in. All right, so you've got that for your reference, and let me close. Geogebra is not super happy when I have like 5 different Geogebra files open at the same time. So we're gonna just have a single Geogebra file open. Let's see. Come on, tablet, exit. Okay, so it shouldn't matter which version of GeoGebra you're using, like We're not really using any fancy tools. Like we're really just going to be entering things into the input bar this time. And so that said, can you see my input bar at the bottom?
Yes, but it's tiny. I think that's my, because I'm on my laptop here.
Okay.
But as long as you're saying what's in it, I think it'll probably be.
Tiny, tiny.
maybe I
Let
can change
me
the,
see if
but I can go, yeah, if I change to 100%, oh, but then I can't get to it. Yeah. I could open this on my desktop instead, and then it would be a lot bigger, which maybe I should do.
is that
It's much better for me.
Oh yeah,
okay.
that's better. Yeah, that's much better. Yeah.
Okay. Super giant.
Gigantic fonts, yes.
Yes.
Yeah, that's great.
Do we want our grid on this time? I already turned my.
So I'm gonna hide my axes and I'm gonna hide my grid again. Okay, so I'm starting out with, you know, blank. I've got nothing in here. We could use our point tool to define our points, but let's just from the beginning use this input bar. Now, a lot of the things, so when you enter something in the input bar, you can either name it when you input it, if you want it to have a specific name, or you can just input it and Geogebra will assign it a name. Typically, I just input things and let Geogebra assign it a name. And then if Geogebra gives it a name that I don't like at like a later step, then I'll change them. But typically, like, you know, it's better to let Geogebra name things, I would say, normally, because you don't want to accidentally call something the same name as something that you already have. But for our purposes here, you know, we'll name a lot of things just so that we have consistency and everybody's stuff is named the same thing. So for instance, if I wanted to put the point A at 0, 0, I could type A equals open parentheses 0, 0, close parentheses. But Geogebra is always going to call the first point A. So I'm just going to put 0, 0. And zoom, whatever, it's going to be the same size. I wish my algebra would show up bigger, but I think it'll be okay. So that gives me my point A at 0, 0. And then I want my point B to be at 1, 0. And notice Geogebra like closes my parentheses for me in case I forget. But if I like, see how it shows up red if I don't have my parentheses closed. And then, you know, it's green for go, like we're good. I've closed my parentheses. So I've got these 2 points, A and B, and they're gonna, you know, do all the things. For this one, I'm not gonna draw that bounding circle just because I think it's gonna, especially as our n gets big, it's really close to the polygon, and so you know, we don't need it. And I will say, I'm going to show you, I'm going to include a number of things in this construction that you don't explicitly need in order to get those final petals, but they do give you context for the elements of the motif. And depending on if, you know, you wanted to go further with this, you may need like some of these bounding circles and things to help you define other elements. So that's why we're going to include some of these things. All right, so the next big thing we want to do is introduce our slider. And so you have a little slider button. Okay, if you've never played around with it because you're whatever, maybe intimidated by it, those of you that have used Geogebra before. It's really you know, it's pretty simple, and it just holds the value of a variable. So I'm going to click on my slider tool, and then we can put this wherever. So I'm just going to put it below, and you just click somewhere in your window, and we want it to hold an integer value. And notice when so I had it called a number, and it was by default A. And when I click integer, it defaults to N. In mathematics, N is the default variable for an integer. And so that's why we typically use that. And you can always edit your min and max later. Like if you want your rosette to go up to 100, you definitely can. 1 to 30, I think is totally fine for me. But we do want to make sure we're incrementing it by ones, especially if, you know, we want to make sure we're including all those cool odd numbered rosettes. All right, so that gives me my integer, and right now it's not doing anything. It's just holding an integer value.
Just a second, Sarah.
Yeah.
I'm like really like not quite there.
Okay.
So I'm on slider. I click on the slider.
Yeah. So click on the tool.
Choice. Yeah.
And then just click somewhere in your window.
Okay. Thanks.
And we want it to be an integer incremented by 1, minimum 1, maximum, you know, the default 30 is fine.
Okay, great. Thank you.
You're welcome. All right. So now I have this thing I can work with, so that, you know, as we build this, we actually kind of see something happening. I would recommend, you know, leaving it in the like 8 to 13 range. I'm going to leave mine on 11. I'm going to make an 11-fold rosette as the default, because hey, you can't make an 11-fold rosette with ruler and compass or origami. So let's make an 11-fold rosette in Geogebra. All right, so now we're going to make our first sequence doing the thing that I explained, where we rotate point B around point A. And so you can copy and paste this, but I would recommend typing it just to kind of get the practice in here. And so it doesn't matter if you capitalize. I'm really bad about not capitalizing, but GeoGebra will correct it to be capitalized. So we want a sequence. So I'm going to type sequence. And notice, you know, it pops up some suggestions of different ways you can build a sequence. So you can just build a sequence with an end value, and that would create like if I put a sequence of 5, it would just create the numbers 1 through 5. If I created a sequence with a start value and an end value of like sequence 2, 7, it would make the sequence 2, 3, 4, 5, 6, 7. Okay. But what we want are one of these more complicated sequences. And so I want a sequence of rotations. So I open my parentheses and I put rotate, because that's the command to rotate. And again, when I put this command in, it gives me all kinds of helpful you know, ways that I can rotate something. And so in my rotate, again, I'm going to open parentheses. And now I want to tell it the thing I'm going to rotate. So I'm going to rotate. Here's where capitalization matters. Okay, so when we name something, we have to be careful about whether we're naming it lowercase or capital. So I want to rotate capital B, comma, and then I want to tell it how much I want to rotate it. And I want to rotate either 360 degrees times k over n, or 2 pi radians times k over n. So either way, you'll have to use this little box over here to get either a degree symbol, which I don't know why that one didn't embiggen. There's the degree symbol if you want 360 degrees. Or let's see, where's my pi? Pi is around here somewhere. Oh, it's what? I feel like this is like tinier than usual. There's the pi. So I'm going to type 2 and then pi k divided by n. And so right now, B and N show up in blue because those are named objects. B is a point, N is this integer value that's held by my slider, but K is grayed out because GeoGebra doesn't know what K is yet. But I tell it that that's what I want to rotate, and then I go outside those rotation parentheses, but I'm still inside my sequence parentheses, and I'm going to put a comma, and now I want to tell it that K is the value that I'm going to iterate, and I want to start with K equals 0, and I want to end with K equals N. And so notice, right, I haven't even hit enter, but that thing I'm trying to construct already shows up. And I'll make this nice and big so that you can see it.
Sorry, I started out in GeoGebra 6, and I'm not able to get that, the thing to pull up pi. It's not pulling up on the right.
Is there, so when you click in the input bar, does the little alpha symbol
Is it on the
show
bottom?
up?
Mine's on the bottom left. It looks
No,
like a
it
keyboard symbol.
doesn't. Huh. Well, I might just switch over if I can't figure it out. Very mysterious.
I think you can also, I wonder if it also works if you just write pi.
Yeah, it does. I tried it.
Oh, it does.
But
Okay.
I put it in the
great.
chat too, but yeah.
Okay.
Oh,
Maybe I'll just
yeah,
try
cool.
that then.
Yeah,
Great, thanks.
GeoGebra's pretty smart. Like it kind of knows what you're trying to do. Yeah, so if you don't want to use the symbol pi, you can type pi. Okay, and so you can always find that sequence again by double clicking on that thing in the algebra view. And here, I don't like lowercase l's in my naming of things because they always look like an I or something. And I forgot to write capital L1 equals my sequence, which is what I really wanted. So I'm going to right click on this and I'm going to rename it capital L1 because I like that better. Sometimes GeoGebra defaults to like capital L1, sometimes it does lowercase. I don't know why, sometimes it picks one or the other. All right.
I'm sorry, Sarah. It's just like a nanosecond goes by and I just missed that thing. So I'm trying to rename.
Okay, so what I
clicked
did,
on that. I got my box.
yeah, so I right clicked on the thing and then rename.
Oh, got it. Okay.
And then you
Okay.
can change it and call it whatever you want. Like I could even call this like vertices or, you know, give it a more descriptive name if I wanted to.
Okay.
And, you know, let's even do that. Let's call it vertices. You do have to, it does have to be a single word though.
Sarah, mine didn't come up, and I'm wondering if I noticed in the sequence you gave us before, which may have been for something else, but it had an A in it, and the one that I've entered doesn't have an A in it.
Oh.
Does that make a difference?
It does. I forgot to put
But how come
comma
yours
A.
does then?
I
How
don't
come
know
it
why
didn't?
mine.
Mine didn't. It just knew
I
what
don't
to
know
do.
why mine worked. That's really weird. GeoGebra just knew I wanted
the
to
magic
rotate
touch,
about
it's not
point A.
there.
But yes,
Okay.
we do need the comma A because we do want to tell GeoGebra what we want to rotate point B about. And you can put a space in or not. It still we'll see it. I apologize for not putting that A in there. That's kind of important.
Mine still didn't come up though. Is everyone else's just growing?
Hit enter, yeah, and then move the slider.
I think I did. Oh.
Did you only have your slider on n equals 1?
Mhm.
Yeah, it doesn't rotate it if your slider's on 1.
Got it.
Yeah, and so that's even, you know, that's even fun to play with just as is now, right? It's like, ooh, I have equally spaced points.
Yay.
All right, now again, I want to kind of emphasize why we entered this from 0 to n. So from 1 to n would create n vertices. So like if n is 9, 1 to 9 creates 9 vertices. But the reason that we want from 0 to n, which actually creates n plus 1 vertices where the first and the last are on top of each other, is so that when we're constructing, for instance, this next thing that we want to do, we have to have, so like the next thing we're going to do is we're going to build the edges of the polygon, okay? And if I say either started in 0 and ended at n minus 1, or started at 1 and ended at n, then when I'm trying to, so like the rule for building these edges is going to be to go from the nth or the kth to the k plus first, okay? And let's say I started with 1 and ended with n. Well, if I do that, then I don't have a rule that easily gets me the line segment connecting my last vertex back to my first. And so by letting my first vertex also be my last vertex, then I am going to have a nice rule that connects me all the way back around. Okay, so let's do this. So this one's going to be our polygon edges. And I'm going to go ahead and call this polygon edges. You have to be careful calling things polygon. You can't call it polygon because there's already a command for polygon. So you could just call it, we could just call it edges if we wanted to, but I'm going to call it my polygon edges. And so I'm going to write equals this time, sequence. And so it's going to be very similar to what we did before. So polygon edges is going to be a sequence. And this time it's a sequence of line segments. And the command to draw a line segment is segment. And then you have to, not segment, helps if you can spell. So line segment just requires 2 points to define a line segment. And now, you know, it's not like when you're building this thing up using the tools and you can just click a point and click a point. We have to tell it where to get those points from. And we're pulling points from that list of vertices that we just made. So my line segment is going to be from an element of my vertex list to the next element of the vertex list. So the way we can indicate that is that my line segment is going to go from an element of one list, comma, element. So it's a segment from an element to an element. Okay. And then inside element, we have to tell it, okay, well, what element do you want? And so we have to tell it which list we want to pull an element from. And I called my list vertices. So that's the list I want to pull from. And same thing over here. I'm pulling from the list vertices. And so we do a comma after the list that we're going to pull those elements from. And I want to draw a line segment from the first to the second, second to third, third to fourth, fourth to fifth, fifth to sixth, etc. So I'm going to create an index variable k, and I'm going to draw from the kth to the k plus first. But that's not enough. If I were to just hit enter now, Geogebra would say, what is k? That doesn't make any sense. So inside my last set of parentheses here, I'm going to put a comma and then define my index variable k. And now this time, I only need to generate n edges. So I'm going to go from 1 to n. But notice my first endpoint of a line segment is the 0th point from the vertex list. And my last endpoint is going to k plus 1. So it's going to n plus 1. And so it's actually going to be the 10th vertex from my vertex list if n is 9. So that's kind of why we needed that extra overlapping vertex here. Questions about that one?
Hang on 1 second, because mine's not working. So I'm just comparing my equation to yours to figure out what I missed.
So this name has to match up with whatever you called your previous list.
Oh, does it need to be capitalized? If
you capitalized it, you need to capitalize it.
That's
So
the problem.
anytime you're calling something by name, it has to be exact.
Yep, that was it.
Sarah, I have a technical question about GeoGebra.
Uh-huh.
So don't ask me why, I don't know. I can no longer see the column of algebra on the left anymore.
Okay, so you should be able to go view algebra.
Okay, thank you.
You're welcome. I like easy to answer questions. All right, so now we have our list of vertices, our list of polygon edges. So this is L1 and L2 in the handout. And now there's a number of different ways you can construct a lot of these other things. But because I wanted to actually create the petal polygons, I wanted some specifically named vertices to kind of help with that. And so there's oftentimes like, yes, you can have the algorithm do everything. Like I could make a sequence of midpoints without defining a first midpoint. But what I found is that I kind of want that one midpoint to have a name so that I can refer to it later. You know, and so the way that I'm constructing this is not the only way that this can be constructed. I actually this is very different actually than how I constructed the first one that I shared on social media. And I kind of, over this past week, I've like reconstructed this thing like 4 or 5 different times, trying to find what I thought was not the best, you know, who's to say what the best is, but one that's workable with things you may want to go further with it. And that also will kind of, you know, make the most sense and be easy to enter. Okay, so the next thing we want to do is we're going to define a specific point C that's the midpoint of our first polygon edge. And we can do that just by defining a midpoint. And so into my input bar here, I can type C equals, or I could just type midpoint and do the command. And since C is my next unlettered, you know, my next letter for a vertex, GeoGebra is going to call it that anyway, typically. So I want a midpoint between my first element in my vertex list and my second element in my vertex list. And so that's what we're going to type. So we want element of my vertices. Maybe I should have just called it vertex, but whatever. My vertices list, the first element, and then comma, element from my vertices list, the second one. So I want the midpoint between the first and second elements of my vertices list. And by naming this point in terms of elements of a list that's dependent on this integer that's held in my slider, you know, if I change something, it all changes, right? So I don't have to change things individually. And so that defined that point C.
Oh, got something wrong again. Let me see, illegal argument.
Do you want to
But
see
I
how I entered it?
Yeah,
Yeah, mine isn't working either.
I didn't capitalize element.
You shouldn't have to capitalize element. The main thing that has to match up is the name of your list.
Yeah, I capitalized that like I did last time. So vertices, comma, 1. Oh, there's not a space after the comma. Does that matter?
The spaces shouldn't matter.
Vertices, comma, 1, elements. Oh, that's it. I'm missing a comma after that. And parents, let's see. Element. Vertices 2. Let's try that. Yes.
Everybody else good?
Can you keep it up for a second?
Yeah.
Tara, how did you get that box to show up again? You just right clicked on C in the algebra column?
So I double clicked.
Oh, double click. Okay.
It hasn't named my point. It's there, but it's not named. Maybe because I might have
So
the
does it
name.
have a name over in your algebra?
Oh, when I click on it, it says, oh no, maybe C is the polygon. Oh yeah. Yeah, it has an A. Yeah, when I clicked on it, the C showed up.
So if you want the name to show up, you can right click on it either in algebra or in the graphics view and show label. So
Okay.
you may have your preferences set to where
Right.
it doesn't
Yeah, I
show
turned off
the
points,
label.
right, yeah.
We're not going to have a whole lot because of the way we're building this algorithmically. Our screen's not going to get crowded with labels. So the few things that do have a label, it's going to be useful to see their labels. So I would recommend leaving the label visible. All right. So then the next thing we want to do is we're going to build a sequence of those midpoints. And we're going to build that almost exactly the same way we built our sequence of vertices, except this time, rather than rotating point B, we're going to rotate point C. And so here's the cool thing about code is I'm just going to double click on my vertices definition over here in the left-hand column, and I'm going to highlight this definition and I'm going to copy it. So I'm going to do Control C, but you know, you can write, well, I don't know, I guess you can't right click and copy, whatever. So I'm going to highlight it and Control C to copy. And then I'm going to hit cancel to close it. And then my input, I'm going to call this, let's see, I can't call it midpoint because that's a command. I don't know. Is it easier for y'all if I just call it the same things that's in the handout? Maybe, I don't know. Maybe I should have done that to begin with, but I like having descriptive definitions often. I'll call it mids equals. And then I'm just going to paste that right in there. Except I'm going to change B to C. I mean, you can retype it also, but I'm kind of lazy.
Oh my gosh.
Was that a good, oh my gosh?
Yeah, that's great. I gotta turn my microphone off.
Oh, it's good. I love it. I like having the like cameras on, mics on. It's good.
Are we officially coders? Like, what is this called? Because it feels like magic. What are we?
Yeah, no, I mean, this is code. Obviously, you know, we're not, I mean, so there is like a code box, like where you can actually run code in GeoGebra, where like, you know, when you do this, it runs a bunch of lines of code and that sort of thing. So what we're doing is a little bit simplified, but it's definitely code. You know, this is code. All right, so we've got our midpoints. This next bit, we don't strictly need in order to build our rosette, but I love seeing these bounding circles because they really are the thing that defines the length of the petal edges and that sort of thing. And I know I said I didn't plan on going that long today, but it's going a little bit longer than that. Things always take longer than you think they are, right? So Paul, if you have to leave, it's
Yeah, I'm gonna have to leave in just a second because I have another Zoom to go to, but this has totally been awesome. So totally looking forward to coming back to this.
All right, so the next thing we're going to do is we're going to build these circles that are centered at each of the vertices and have their radius defined by those midpoints. Okay, so I'm going to call this bounding circles. And the way I'm naming this with like a lowercase first letter, but then capitalizing the second letter, that's called camel case. Like if you're program, like that's a pretty common standard for naming things in computer programming. So I'm calling my list bounding circles, and then it's going to be equals, and then I want a sequence, and I want a sequence of circles, and the command to draw a circle is circle. And then there's a number of different ways we can define a circle. But we want to define a circle by a point that's the center and a point that's the radius. So I'm thinking in terms of point. And my 2 points are going to be elements from my vertices list and my mids list. So the first, my center of each circles is going to be an element of my vertices list. And I want the kth element of my vertices list. And then I got to make sure I go over the correct number of parentheses. Element, comma, element. The second element is going to be from my midpoint, mids list. And again, I want the kth element. So I'm going from the first vertex to the first midpoint, second vertex to second midpoint, etc. And then again, now I just have to work with my index variable. So I go inside my last parentheses, put my index variable, and from 1 to n. And your happy little ring of circles should show up.
If my midpoint is named C, which I guess most people's is, why don't we enter C?
Okay, because we want not just the first midpoint, we want all the midpoints. Okay. So I want to be able to not just draw a circle with center B and radius C, but I want a circle with the first vertex and first midpoint, the second vertex and the second midpoint, the third vertex and the third midpoint, etc.
So how do I know what to put in there? Would I also put mids? Would everybody put that in, or what?
Yeah, so whatever you named your list of vertices, that's what should go here. So in the handout, that was L1.
Have that L1.
And then whatever you named your list of midpoints in the handout, that's L3. That's what would go here.
Oh.
And by putting that K inside element, you're telling it that you want the first vertex to the first midpoint, the second vertex to the second midpoint, all the way up to the nth vertex to the nth midpoint.
Okay, I think I completely skipped that step. I think it took me so long to make the point C that I haven't even gotten to that. I haven't made all the midpoints. That's why there was no list to go off. That makes sense. Okay, so
Do you need to see that one again?
No, I can get it off. I think, is it on the handout?
Oh, yeah. It's on the
Okay.
handout.
What I've been doing is, if my typing is not good or it's not coming up for some reason, I just copy and paste it from yours, and then it's like, oh, it just works out perfect.
I've been doing the same. I'm like heroically trying to do it myself. Then it
And
fails.
it doesn't work out.
Then I
and
copy and paste.
Yeah, it's something about the I don't know. There's something, the magic touch. You have to know. It's the commas and the
Parentheses.
See,
I'm
now
waiting for Google
all I
to
did was copy
correct
and
me.
paste, and I have all of them. It's perfect. So no problem.
Is everybody good to go to the next step?
Yeah.
Cool.
Yeah.
Yeah.
All right, so the strict order here, like we didn't have, obviously I needed the midpoints before I did the circles, but I'm gonna put in my radial divisions now. I could have put them in sooner. So one thing I do wanna point out, and there's directions for the even rosette that has a simpler definition in that same Google Doc below the other one. For that, you only need n-fold radial divisions to make it work. But if I want to account for all the odd rosettes, we have to have 2n radial divisions, which is typically what you do when you're drawing with a ruler and compass, right? Like you draw 8 lines, like if I'm trying to make an 8-fold rosette, I draw 8 lines through the center that gives me 16 divisions of the circle. And so that's why for these radial divisions, I'm going to call this radial divisions so that I have a nice descriptive name for this sequence that's L5 in the handout. Oh, actually, I'm going to enter it the way I have it with the asterisk. So this is kind of I think a simpler way to do it. So I could just type in my radial divisions, but I think it makes a little bit more sense if we actually have a starting line segment and then we just think about rotating that line segment. And so what I want to do is I'm going to define a line segment from A to B, and let's call it F. And you could actually use your line segment tool here if you wanted to, and then click A to B, and that would work too. But you can also type what I had in the handout. That's just F equals segment from A to B. And the reason that I kind of like this rather than what actually ends up showing up in the definition in GeoGebra is just, I don't know, I think it's easier to think about rotating the segment rather than rotating the end point. Okay, so let me try this again. So these are my radial divisions, and this is a sequence now. And I want to rotate. So I'm going to rotate line segment F a certain amount, which I'm going to leave blank for now, about point A. And I'm going to use K for my index variable, and I'm going to start at 1. And no, actually, just kidding. I'm going to start at 0 because, again, this is something that I want to have a redundant one at the end. And I'm making 2n radial divisions. And so the difference between having 2 pi k over n is that here we want 2 pi k over 2n, which you could just write as pi k over n. Which, you know, I mean, I have it as 2 pi k over 2n in the handout to make it, I think it's a little bit, you know, more obvious mathematically. What we're doing is we're dividing it into not just n pieces, but 2n pieces, but the 2's cancel. So for sake of entering it more efficiently. And notice here, right, these are radii, so they hit the vertices, but they extend past the midpoints, which is fine.
Sarah, excuse me, Sarah.
Yeah.
Could you say that again about why you don't put 2 pi k in? It cancels out. Where's the other 2 that cancels it out?
Oh, here, let me enter it. So I'm doing radial divisions. My name. Sequence of rotations f about, so 2 pi k over 2n, which notice I'm putting parentheses around the 2n about point A, where k runs from 1 to 2n. So I'm going to have to leave this up because once I click enter, Geogebra doesn't remember this anymore, and Geogebra translates it into a different sequence.
Okay.
So the 2's that I was talking about are this
Yeah.
2 and this 2. So you've got a 2 in the numerator from your 2 pi, and the 2 in the denominator from the 2n, which is why I just entered it as pi k over
Right.
n.
Okay. But I guess I'm gonna have to go back and look at the notes because I can't quite remember why 2n.
So here it's 2n because look, my n is 9 right now.
Oh, that's right. You said that at the
We need
beginning. Right.
18
Yes,
divisions.
Right. Okay. Mhm. I understand. I remember now. Thanks.
So now that it's entered, right, like you can kind of see that when I double click on it over here, like it totally changes the definition. And I actually, I'm going to edit it in here because I think it's silly that they rotate point A about point A. And so I'm just going to change this to A. But you don't have to do that. Like it's fine. I hate when they rotate a point about itself. Like, let me have like 18 points at point A for no reason whatsoever. And I'll share this this Geogebra file on the Patreon so you can kind of see what mine looks like in the end. All right, so we've got our radial divisions now. And so the next thing that we want to do is I'm going to define a bounding circle, or the inner circle that's tangent to all these bounding circles. And the main reason that I want to do that, so again, I don't need it, but one, I like it aesthetically because I'm obsessed with circle packing, and I think it really kind of makes the whole thing happy, and the patterns all live in circles. But two, what that allows us to do is kind of have a singular thing that intersects these radial divisions rather than having to ask, okay, where does the kth radial division intersect the kth bounding circle? And so we can just ask, where does the kth radial division intersect this one circle? And so to define this circle, well, we need a center, which is point A, and then we need a point. And the point that I want to use to define this is this point right here, okay? And so let's take a look at how we're going to define this. So I'm going to call it circle C, and this is a circle with center A, and the radius is going to be defined by an element no, excuse me, an intersection. So the command for intersection is intersect. And it's going to be an intersection of two elements. So intersect element, comma, element, and let's think about which things we want to intersect. Well, one of them is the radial division. And let's say I want the first one, because I only need one point here to define this. I'm not trying to generate a sequence of these things. There's only one. And then this is my bounding circle, and that's what I want the intersection of that radial division is. And so I called that bounding circles and the first element. So if we kind of think about order of operations here, my circle is defined with center at point A and radius defined by this whole thing, which is the other point. And then that other point is defined by the intersection of these 2 points. And these 2 points are defined by an element, by the first element from their respective lists.
Can you please just say that again?
Yeah. So to define a circle, we need 2 points, the center and a point on the other end of the radius, right? So a point on the circle. So for us, our center is at point A and our radius is this thing, okay? So I'm trying to define this point right here.
Right.
And I'm defining that point by an intersection of 2 things. Okay, and so the intersect command needs 2 inputs, and the 2 things that I'm trying to intersect here are elements from 2 of my lists. The first one is an element from my radial division list. It's the first element from my radial division list. And the second one is the first element from my bounding circle list. And so the intersection of those first 2, first radial division and first bounding circle, gives me this point that's defined a circle.
That's beautiful. That's
but
great.
no, that's not, that didn't do what it was supposed to do. So hang on a second.
Hey, Sarah,
What did I do?
I typed in exactly what you had. Mine is where it's supposed to be. The only thing that I did differently was not change that rotation around point A to just say A. But that wouldn't have done it, would it? Like that's,
oh, did I type a rotation?
no, you didn't
I
type
think
a, you changed,
order.
you changed the way that GeoGebra, you open it back up and where it had, where GeoGebra had something rotating around, or rotating point A around point A, you changed it to just say A.
Yeah, that shouldn't.
But that shouldn't do it.
That shouldn't do it. Let's see. So why did this do this? Let's investigate.
Because the circle should be sitting just inside all of the other circles, right?
Yeah,
Yeah. So that, I mean,
oh, okay.
doing
So
it, so
here,
something's
okay.
right.
So I can explain what it did, and I think it might have to do with how I maybe, let me see, what did I do for my, did I do 0? Yeah, okay. So my radial divisions, and this is what I changed. That so this should have been 0 to 2n, and for some reason I put 1 to 2n when I entered mine for my radial divisions. And that made all the difference. Because what was happening was, this was my first radial division, because by starting it at 1 rather than 0, I was having the rotated one be the first one. And that does intersect the bounding circle here. And that's why it was drawing the circle there. And so if you copied the code in my handout, then yours worked correctly, because you did, you know, what I meant to do, but then didn't do. But what I really want is to think of this as my first radial division. And so that's why I want to start by rotating 0. So that fixes that. All right, so that's that gets us this point. And then now I just want this this intersection. And maybe, you know, maybe it would have been simpler if I had defined this point first. Probably. I probably should have defined this point first, and then I could have just drawn a circle with A to point D. Actually, I'm gonna do that. Watch me delete my circle. Bam, it's gone. And I'm changing my code, you guys, because this is better. So I'm gonna define this point D first. And I'm gonna call D the intersection of the element from my exactly the same list 4 and list 5, but it's going to be my bounding circle with element 1 and my radial divisions element 1.
And this is just to clarify, that's just so to not worry about the like off by 1 issue or whatever, you're just using that point.
So that actually, I mean, this would have been affected by that off by 1 issue too. Because like, so I had a problem with my radial division. So if I had left this starting with K equals 1, it would have again found point C instead of this intersection. So it's just going to find the first intersection of a radial line with whatever the first element of my bounding circle list is.
Sarah?
Yeah.
Could you please just put up again what you wrote in to define the intersection of your first segment with?
Yes.
Yeah. Because I was copying that in and I didn't.
So it's exactly what I mean, it's exactly basically what it's the intersect element L41 element L51 from the definition of that inner circle. So I'm sort of swapping those two things, and then now I'm going to define my inner circle as just AD.
I'm copying it in right now.
I just kind of want to show that, you know, I mean, there's different orders and different ways that you can do things.
Okay, I hope that works. Thank you.
And so this would be L4 and this would be L5 if you're.
I didn't, something happened, Sarah, I'm sorry. Intersect. So you had D equals that?
So you can either type D equals this or just type intersect, and then GeoGebra will call it what you want to call it, whatever it, you know, it'll give it a name.
All right. Intersect element bounding circles 1, comma. Element radial division. 1. Yeah, that should work. Oh yeah, no, it didn't work. I don't know.
So are your lists called those
Yeah,
names?
everything was groovy, and I did what you did.
Okay, so then you may have the issue that I had. So double click on radial divisions and make sure your K goes from 0 to 2n. I accidentally had it.
It does actually do that.
Okay. So I would say if you're having issues, you may be better off just defining that inner circle first and then the intersection.
I'm just gonna have to say, I'm just gonna have to watch from now on.
Well, do you want me to go backwards and do it like I had of it in the handout?
If you don't mind, that would be good for me, but
Yeah.
I know there's people that are like already knowing everything, so.
I don't think everybody already knows everything.
No,
They wouldn't be here, right?
I know circle equals,
Yeah, so by defining the intersection in the complicated way, like it allows me to give a simple definition to my circle. Okay, and so what I have in the handout, and I'm just gonna delete those things. So what I have in the handout is a complicated definition for the circle and then a simple definition for the intersection.
okay.
So in my handout, I have C equals circle with center A, and then the radius is the intersection of the first element of my bounding, nope, that's lowercase, bounding circle. I can't type. Circle, so the first element of this one, and the first element of my radial division. And this, if I hit enter, Geogebra might change that. I'm not sure. Maybe not. And so in the handout, this is L4, where I have bounding circles, and L5, where it's radial divisions.
Okay.
And so if you wanted, you could just copy paste the thing from the handout and replace L4 and L5 with bounding circles and radial divisions. And the order here doesn't matter. I could have had radial divisions first and then bounding circles.
All right, I'm gonna attempt to do that. Thank you, Sarah.
Let me know if it works.
Okay. It's gonna be a little complicated. I mean, I actually can't because I don't have the handout available to me.
Oh, let me,
So
I'll paste in the chat again.
In case you can't open it, Jeannie, we can also just paste the
oh, the definition. Okay.
yeah, just that particular one.
So this is,
Oh,
these
that's
are kind of
okay.
the two things.
But if you haven't defined if you haven't defined L, how is that?
What do you mean? So in the handout where it says L4 and L5,
Yeah.
so L4 replace with bounding circles and L5 replace with radial divisions. So L4 and L5 are just the names of those lists. So I could rename this, you know, if I wanted to as L5.
All right. I think I know what the problem is. You guys are being very patient. Thank you.
Meanwhile, I mean, you know, we can just play with our sliders, right?
Does it not work for n below 6? Like when you generate, I copied and pasted them all by the way. So for when n is equal to less than 6, it just doesn't look like a rosette, but from n equals 6 when it's working. So is that just the nature of the thing?
Yeah, yeah.
Oh, that's really good.
Or at least, I mean, this method of drawing the rosette with the midpoint of the edge.
I like seeing visually how the outer bounding circles get smaller and smaller, and how the inner circle gets bigger and bigger. And they're only equal in size when they're at 6.
Mhm.
Yeah.
It's like good for the brain. Like you know it, but until you see it, it's like, oh yeah, well I knew that, but now I'm completely sure of it, and I could, you can see it and you remember it better.
Wait, so at 6 they're the same size?
I believe so. Maybe I'm just seeing
Yeah,
that.
yeah.
I just noticed it because you said it, and I was like, oh yeah. So that's probably maybe a reason why when it's less than, it just isn't quite right. But we don't expect to draw rosette patterns that way anyway.
Yeah.
But that's maybe a barrier, right?
That central
boundary.
circle needs to be greater than or equal to the outer circles.
That's so cool. You kind of
And what's
discover
really
a
fun
practical
is like,
Yeah.
let's change our slider to have a maximum of 100.
loop.
My God.
Wow.
And then, oops, I can't see anything with it being this big. It drives me nuts. Okay, hopefully that works. So then, woo, they get really tiny, right?
Oh my God. Whoa.
The limit, for those who would do calculus, right? The limit of the outer ones would go to 0, the outer radius would go to 0, and the inner radius would approach your original bounding circle. Would approach 1. Whee. We'll go to much more sensible numbers. So, how's it going, Jeannie?
Hooray! I can announce with victory. I just got it. You guys, thank you. Thank you.
Fantastic.
Now, if I can just figure out how to get back to Zoom. Yes, I can. All right, thank you.
All right, so then the next thing that we want to do, even though we already have a line segment here, I want to define this line segment between point A and point C, just to have a simple name, just to make my next definition simpler. Okay, like I don't need to do this. I could use the definition of that, second radial division as the name of that thing, but rather than having to enter element of radial divisions, comma 2, whatever, I just want to give this thing a name. And so we call the line segment from the center of a circle or center of a polygon to the midpoint of the edge an apothem. And so that's why it says apothem in your handout. And so I'm going to call that apothem G. And so I'm going to write G equals the line segment. So just segment from point A to point C. So that just shows up on top of one of the algorithmically produced radial divisions. And so if I were to hide, line segments F and G, the thing underneath would still be there. But I have those just to help me make easier definitions. And me just saying hiding line segment F and G kind of reminded me that I much prefer to sort my list by object type than sort of order of order it was produced. But I don't know, maybe it's better for you to see the construction order. I don't know, whatever, I'll leave it, it's fine. All right, so then the reason I wanted to call this its own thing is because now we're going to define those parallel edges. And it's that apothem that we want to draw things parallel to. And so the parallel sides of our rosette petals always pass through these, so point D, so those points of tangency between the bounding circles and the central circles, but they're parallel to the nearest apothem. And so what I want to do is I want to construct a line that's parallel to line G, but that passes through point D. And all we have to do to construct that is use the line command, which allows us to either enter 2 points or a point and a line, all sorts of things. So I want it to pass through point D, and I want it to be parallel to G. I had to think about that for a minute. And if I hit enter, Geogebra immediately calls it H. I could have entered H equals line DG, but I didn't have to.
Sarah?
Yeah.
So actually, I don't have a defined point D.
Okay, so you got that circle?
I have the circle, yeah.
Okay, so then
Can I just
define,
write yeah, go ahead.
this is how you want to define your point D. So you can do D equals intersect.
But I don't even have D.
Well, yeah, this is the definition of D. So if you want to put D in there, this is what you need.
I'm sorry. Oh my God. So bad. Okay.
And so it's just like the handout, except instead of L5, I have it called radial divisions.
I got it. So the most recent command was to use D to create a line.
So you drew the apothem, AC.
Yeah, I have all that.
Okay,
That's-
so then,
that's
yeah,
good to
so
go.
then the last thing we did was just a line,
DG.
DG.
Okay.
And so that constructs a line through point D parallel to G.
Okay, thank you.
Now, finally, is when all of the magic happens with like this one kind of line. And so what we're going to do is we're going to take this line, which is line H, and we're going to rotate it around 2n times. You'll notice if you go back and do my even petaled rosette one, we only needed to rotate it around n times. And so you'll see after we do this step, when you move your slider, that for the even rosettes, we actually end up with twice as much information as we need, but we need that much information in order to do the odd rosettes. So again, I'm going to set up a sequence. I'm going to call it petal edges. Maybe that's a bad name. Petal sides. I'll call it petal sides, and I'll do, yeah, petal sides, whatever. It's fine. It's L6 in the handout. So I'm going to call it petal sides, and this is a sequence, and it's going to be a sequence of rotations. So I'm going to rotate, and this time I'm going to rotate line H, and I want to do the 2n rotations. So I can either enter 2 pi k over 2n, or I can just enter pi k over n. And again, I'm rotating about point A. So I'm always rotating about that center point. And I want my k to go from 1 to 2n. And then, you know, everything kind of fills in. And to me, that's a little overwhelming, all of that. And so what I like to do is sort of make, gosh, I can't see anything with this being so tiny. I like to kind of make those a little grayer and a little thinner so that they don't stand out quite so much. But that's, you know, almost all the information that we need. And then I would say the next big kind of final thing to get all the lines for our rosette is to draw an inscribed polygon connecting those midpoints. Before we do that, does anybody need to see the petal side definition again? So in the handout, I have a 2 in front of the pi and 2n in parentheses in the denominator. But I canceled my 2's. Is everybody good?
I'm not good.
You got a question?
I don't know what's the wrong. I honestly don't know why I can't draw a line parallel to my apothem that intersect a D.
So did you have,
The apothem is there. It's called G,
and you have point D,
and I have point D defined as well.
and you entered your line just
I
like
entered-
this?
I entered line L-I-N-E.
Did you do a capital D?
I did a capital D. I didn't do a capital L for line. I'll try that.
That shouldn't matter.
No, I just do the same thing.
So
on
if
the
that's
other one.
not working, try using your parallel line tool. Because if that line segment is there and the point is there, you should be able to use your parallel line tool. And so you could click point D and then
Yeah.
click point G.
That works fine.
Okay.
Thank you.
And now, like if you were to double click on it in the algebra view, does it show it as, oops, does it show it as line DG?
It shows it as line DG just like everybody else. So I'm like, okay, yay.
Sometimes GeoGebra is a little, you know, it's
just
sometimes it's
messing
a
with
little
my
special.
head.
All right, we got there. So maybe we can add that as a little comment in the document. It's like if this doesn't work, try using the parallel line tool. There we go. Great thing about a Google Doc, it's update as we go. All right, so then
So then
this is
people just take this next. I'm sorry, I'm so out of it. But people just take the next command and copy and paste it into their.
so this is the next command.
Okay,
That's what I've been doing just to make sure I get it right. I've tried to type it in, but then every time after I type it in, I just end up copying and pasting it.
Oh, Bryn, you're so smart that way.
I don't know. I mean, I keep getting it wrong on my own. So
I keep typing in insect instead of intersect, so that doesn't work.
It's great.
Sarah, is there a reason, this is a little bit ahead, but I'm gonna try to make my question general. Like, is there a reason why if I write a sequence, I'm not seeing it? But like I click enter and I don't see it in my lists. But then if I type the name of the sequence into the input bar again, it all of a sudden that thing appears. So it's like I apparently did something, but now I can't see it like in the list itself. It's so strange on the algebra list.
I don't know. I don't, so you're defining a list. Are the things showing up?
Well, like I was doing L8 and I defined it, I clicked enter and I don't see it. But then when I just type L8 again into the input bar, all of a sudden I see everything I want to see. But like when I click enter, it disappears again. But like I'm not redefining it. So GeoGebra knows, you know, my parameters and everything apparently because
it's showing up.
It's showing up. And I've done it a few times and like I don't know if anything comes to mind. You don't have to worry about it.
No, what happens if you try to change the way your objects are sorted? Does it show
I'll
up?
try that. Thank you for that recommendation.
Oh, illegal multiplication. What?
Did you put a space between your pi and your k?
I got a space between pi and k. Space between pi and k. K or n, I got to put a space between n and k and a. No. It's the problem with how h is illegal multiplication of h.
You have a comma after h?
I don't.
You need a comma after h.
Oh, hello.
Because you have 3 things separated by commas inside your
gosh.
rotate.
I
The
am learning
thing-
so much, Sarah. Thank you for reminding me of all those things that we used to know.
Yeah, so you've got these 3 things inside rotate.
Mhm.
The thing you want to rotate, the amount you're rotating it, and then the thing you're rotating it about.
Excellent. I'm feeling so smart. Thank you.
All right, so let's see. Let's do our L7 or the outer edges of the petals. And so this will be very, very similar to that sequence of polygon edges. And so actually, do I want to be, I kind of want to be lazy here and just copy and paste my definition of polygon edges. So I double clicked on my polygon edges, which is L3. And I'm Control A, Control C to select all and copy. And then down here, I'm going to call this, I don't know, mid edge. I don't know what I should call this. I feel like I should just call it L7, but I want to give it a more descriptive name. We'll call it, yeah, mid edges, or I don't know, whatever, something dumb. Equals, and then I'm pasting this, and except instead of vertices, I want mids. So it's exactly the same definition as our polygon edges, or our L2. But then in place of L1s, we want L3s. And so at this point, technically we have, you know, all the information there. Like if you were, you know, this is what you would get from your ruler and compass construction, right? And then you would just pick out the pattern. And so, you know, then the question is, okay, how can I pick out the pattern algorithmically? Well, there's a lot of different ways you could do it. But again, I think sort of the simplest way is to define those missing vertices, use that to define a petal, and then rotate the petal. And so before I do that, so everybody got their inscribed polygon connecting the midpoints of the edges? All right, cool. So I hit enter on that. All right, so now sort of the question of, all right, how do I find these missing edges, or these missing, excuse me, these missing vertices, really kind of depends on the two objects that are intersecting to define those edges. And if you look at my definition, I'm using the intersections of this inscribed polygon, so these outer edges of the petals and the side edges of the petals as defining the vertices, okay? But obviously those vertices, like these vertices, also happen to occur at that point of tangency. So there's other ways we could have defined those as well. And so now I don't need to define those vertices for every single petal. Right now, I really just want to define them for this first petal. So I'm missing this intersection, this intersection, this intersection, and this intersection. And so what I did when I was figuring out, you know, what these intersections should be, was I counted. So I'm going to go ahead and type this in, or copy paste it, if you would, from the list. And let's, because I want the point there, because I don't remember which point this is. So I want the point there to help me describe why this is what the point is. So this is the intersection between element L, okay, let's see, L6 is my petal sides. Sides, the 2nth one, and the nth element from my mid edges. Let's see if that works. It does. Okay. So if I'm trying to figure out what this point is, well, I know that okay, so let's think about which of these polygon sides is my first, second, third, first, you know, whatever. So this was my first midpoint. So this right here is my first midpoint edge, which makes this one my last, or nth, midpoint edge. So I'm starting here, and then my last one comes back to that point. So that's why I have the nth midpoint edge there. So that's intersecting this, which I could have just used line H, okay, that would have worked, but I really wanted to keep it in terms of my algorithm and associated with an N. And it turns out that's actually my very last rotation of itself. So kind of as if you count around, this is the first, second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20, when n is 10. So I'm back. So that's my 2nth rotation of that. And so that's why this is the 2nth petal side intersected with the nth edge. So then the next one,
Now,
F.
Sarah, I have to ask a question.
Yeah.
I have an undefined petal side.
Did you define a list called petal sides?
I don't think I did, because did you do that?
So that's all these parallel lines that are gray.
So you selected all those and called them petal size? Is that what you did?
Well, I called it that when I entered it. Yours might be called something else. In the handout, it's called L6.
I don't think I ever did that.
So yours, you know, you can select it, you know, you can click on one of them and find out what Geogebra called it.
Oh, I get it now. Oh, okay. Okay, all right, thank you. Thank you, Sarah.
Yeah, so just whatever that, you know, that list is
Okay.
called.
Okay,
And then same thing for, you know, this inscribed polygon, I called it mid edges. My handout calls it L7, but you know, if you didn't name it when you were entering it, Geogebra would have given it an automatic some other name. So now I'm entering my point F, which is the intersection of the nth element. Actually, hang on, I'm going to be lazy and copy paste. Okay, so this time I want the nth petal side and the first edge. So this is my first edge, and if you were to count around, that would be our nth petal side. So here, that would be our 10th one.
Can you pull that back up real quick, Sarah?
Yeah. So I just copy pasted my definition of point E and then changed 2n to n and n to 1.
Great, thank you.
And I literally just was counting, like I moved my slider a couple times to check it for an even n and an odd n to make sure it worked, you know, in both cases. And that's, you know, that's how I came up with these definitions. And then we want this one. So we have to figure out what number that one is and what number that one is. Again, I'm going to be lazy and I'm going to copy and paste so I don't have to type the whole thing. And this is G. And this time I want, so these are both petal sides. And I want the n minus second petal side. So if n is 10, that would be my 8th petal side and the second petal side. So this is the intersection of the second and the n minus second petal side, which, you know, those are mirror images of each other across a radial division. So, you know, that's kind of nice that it's the nth and the n, or the n minus second and the second, that they kind of, they add up to n like that. That's kind of nice. And then H, be lazy again, is the intersection of, again, that second line, but this time with the nth line rather than the n minus second. And so the reason that we entered all of these points like that, right, is because I don't actually have objects that I can click on my intersect tool to click individual pieces of, because those pieces change depending on what my n is. And so now those points are the vertices of that petal, no matter what I change my n to be. But now I can define a polygon that passes through all of those vertices. And so what we can do is I can either enter my polygon in the input bar and then just list all of the vertices. And you can enter them starting with any vertex. I could start with E, C, F, H, G, or D, but you have to enter them counterclockwise, okay? Or you can just use your polygon tool now and actually select them, which is kind of nice. And, that gives you exactly the same thing as if you were to enter polygon and then list the vertices. Obviously, if you don't enter them in the correct order, it's not going to work out, which is kind of why for something like this, I would just rather use my polygon tool. And now notice, remember when we create a polygon, it creates a bunch of line segments. And so I'm just going to hide all those line segments because the line segments themselves don't bother me, but the labels do. So I'm just gonna hide them. And then finally, we can rotate this polygon the same way we rotated our vertices, the same way we rotated our midpoints. And so I'm just going to copy paste my my vertex sequence, and I'm going to call this petals, except instead of rotating point B, I'm rotating poly 1 or polygon 1. And here, I don't have to do from 0 to n. Like I have 3 polygons right here right now because I have my original mock-up polygon that we drew, and then we have a 0th one and an nth one. So I'm just going to start. I'm going to do 1 to n so that if I do decide to hide that original polygon that I used, I have that ring of polygons defined by the sequence. And now, we can move our slider and we get a nice thing. Now you could also do a similar thing to what we did to make these petals, to make like your central star. But that's going to be quite a bit more complicated because you're connecting an alternating sequence of intersections that have quite a bit different definitions. And so I left that out. But we get a little central star, so.
This is amazing. I've hidden everything to make it look so slick. It's really
yeah. At this point, yeah, like we totally want to hide all this stuff and make it pretty.
Make
right?
it look effortless.
So yeah. Oops. Just keep the petals. Well, I like having my bounding circles.
Yeah, I kept the circles. I like the circles, but yeah, no, I got rid of some other stuff. But yeah, it's just really like very pleasing, very pleasing.
Let's see. Where did my? Oh yeah. I guess we could do. We leave the polygon edges too.
Yeah.
Those are the parts that I like. All right, I guess it kind of depends on just what you want to see. Sometimes the radial. I like the weird eye that grows in the middle of the radial divisions there too.
I like keeping the polygon because you can see the 3 points of the star a little bit as though it hints towards that. So then that's nice.
Yeah. And then you can, you know, I mean, you can start to do stuff like, you know, you could rotate, where is it? You could rotate this polygon about point C to get one that points this direction. And then you could rotate it around so that then you have a ring of polygons that face inward and a ring that face outward. And, you know, you can just kind of keep building on from there.